Okay, what I've got today is just a little circuit that I had initially started playing with and built from scratch successfully. But then I found the same thing on eBay, and it was less than $4 to purchase, including shipping, from China. Where else, right? And it is really quite a useful little circuit. This light is producing the only light in the room right now, and it's pretty darn decent. I wish I could give you a better perspective of just how much light is in the room, but it's definitely brighter than I'd want to have for sleeping. Okay, and you can see it's got some LEDs. 2, 4, 6, 8, 10, 12, 14, what is it? 16 LEDs, 5mm LEDs, going pretty strong. Okay, and definitely enough room, enough light in the room to get around. Now what this is it's running on a 12-volt battery. Now this came from the dump and came out of one of those typical flashlights that like a work light, you know, and somebody just discarded it. The interesting thing about this is, and typical of when you find stuff in the dump, is this here was set up as a bunch of parallel LEDs. In other words, if I show you on the back, first of all, before I unplug it, that's 16 LEDs now running through the converter off of a 12-volt battery that was sitting at 12.7 volts, and it's drawing, I don't know if you can read that, but it's about 67 milliamps is what it's drawing. Now, if I unplug this, I'll show you that on the back, it's all just paralleled LEDs. In other words, the running voltage of this ought to be between 3 and 3.2 volts. Now, the interesting thing is the little buck converter, okay? And for $4 shipped, it's a variable buck converter. Now, I've had that thing running for, I would say 20 minutes, and there's no discernible heat on any of the components whatsoever. Now, this is a fairly small load. The inductor on this is a potted style ferrite, a 330. Now, for those who are interested, I can break this circuit down. It's a very, very simple circuit, and I've built something similar in the past. It's not complicated to make yourself. It's based around the LM2596S, which is a specialized IC for making a buck converter. And you can see it's just a very, very, very simple circuit. There's nothing to it. You've got essentially a couple of resistors, a couple of capacitors, an inductor, a variable resistor, the chip, and a couple diodes, and that's about it. Okay, and essentially what's going on then is a high efficiency conversion from 12.7 volts. Right now I have this set at 3 volts, and the beauty of it is that you can take stuff like this, or for example, you know, when you're in your dollar store and you find a flashlight that's, say, like a puck. I'm sure you've all seen them. They're like a like a circular puck of LEDs, if you will. Now those normally run on a couple AA batteries or whatever, but they usually have a magnet on the back, and they make a pretty damn good light. Problem is that your batteries run out, and what we have around is 12 volt batteries. You know, typically we have large capacity in 12 volts, not in, say, 3 to 4.5 volts. So with this little buck converter, you know, you can make one yourself, or you can pick one up, you know, shipped to your house for $4, and they're really quite handy, actually. And when you think about it, that there was running at, you know, 0.8 of a watt, and I know from dozens and dozens of experiments that the light coming off of that is really good. You know, like it's as good as I've seen a watt produce any other way. Your conversion rate is good. There's no two ways about it. It kind of works like the opposite of a joule thief, and in a lot of senses I actually think that it's a better circuit. And keep in mind that when I do this, because I can set my voltage to whatever exact voltage I want, it holds the voltage. Okay, and so consequently I'm running all those LEDs with no resistors. So it works in your favor that way too, because normally if you were to run resistors and LEDs on 12 volt batteries, you actually lose a lot to the heat that's dissipated by the resistor, whereas in a circuit like this, small buck converter, now you might say, oh yeah, well, it's good for running a few LEDs, but you know, what can it do? What it can do is put out 3 amps of current. You just saw it put out, say, 70 milliamps. So, you know, it's actually a pretty robust little circuit. And, you know, you could get, for example, easily get 500 milliamps at 5 volts to charge lithium-ion battery devices. Dude, just put anything you want with it. So, anyways, I thought I'd share that with you, and if you like more information, just contact me and I'll point you to directly where I got the thing. Thanks. Have a good night.